A very good afternoon to one and all. Uh, so, heading towards the second session of the day, I would like to introduce Dr. Ghanapriya Singh. Dr. Ghanapriya Singh is working as an assistant professor in Department of Electronics and Communication Engineering at NIT Uttarakhand since 2013. She has received her PhD degree in signal processing from Indian Institute of Technology, Delhi. During her research at IIT, she was working on a project with ST Microelectronics, Santa Clara, California, USA. Her research work done at IIT was also showcased at CES USA, that is the largest consumer electronics show. She is an inventor on 5 US patents, 4 granted and 1 published, and a European patent. She is an investigator in the project funded by the Ministry of Electronics and Information Technology, Government of India. She has authored in High Impact Factor SCI Index Journal. Her current research interests include context awareness, image processing, speech processing, signal processing for IoT, and gate analysis. So I welcome you, ma'am. So I request to Dr. Ghanapriya Singh, kindly proceed with your expert lecture.
Thank you so much, sir, for your kind introduction. So I shall present my lecture and we shall go forward. Sir, is my screen visible?
Yes, ma'am, your screen is visible, ma'am.
I am trying to put it to full screen, just a minute.
Ma'am, it is clearly visible, yes.
Okay, thank you. So I'll be taking a lecture on smart wearable for healthcare, signal processing and applications. And to start off with, we shall start with what is wearable technology. So we shall start off with what is wearable technology. The wearable technology, we need a definition. So the definition was given by Tamura T and Chi. Just a minute, sir. How to remove this screen? I'm unable to see my own. Okay. Right. So the definition was given by Tamura and Chen in 2018 that the seamless healthcare monitoring, advancement in wearable, attachable and invisible devices. In Springer, a wearable device is defined as a monitoring modality that is worn by a user in daily life. It is usually integrated into items used daily: watches, eyeglass, ring, vest, gloves, belt, shirt, brazier, shoes, necklace, and bralette as an inseparable component. An individual customized size is usually required. It often moves with the user ubiquitously without any apparent or obstructive parts. So the foremost in the definition itself, we know that wearable technology needs to be unobstructive and should be able to be worn by the person. It could be in any form whether it is a smart watch, which is widely publicly available nowadays, whether it is a smart eyeglass, a smart ring, whatever thing. So by these wearable technology, I wish to specify and focus on a particular application, which is healthcare. How can we have a preventive and monitoring healthcare using this wearable technology? So there are various wearable devices available, which we shall be seeing through. First, mm, these wearable technologies, in earlier times, it was science fiction. So even when we were seeing in movies, in 1969, a science fiction movie, Star Trek, we were seeing that the movie was representing a head-worn device in which the actors were able to see outside the spacecraft. These same science which was a fiction in 1969 is now a reality, and it has been reality since past 7-8 years. This reality is now by Google glasses. We are able to detect and classify the objects using these Google glasses. So what was once a fiction is now a reality. So what else can we go in forward? What wearable technology can we use for our own health? So for wearable technology, one of the most important component is seamless sensing. By seamless sensing, we need that the sensors be embedded upon the body, and it should be able to monitor continuously. So the next question which logically arrives is, what are the sensors that should be available? What are the things which should be able to be monitored? So few of the sensors that could be monitored using wearable technology are EEG. Let us start with an EEG. What shall it be able to monitor? It shall be able to monitor and track behavioral health, brain, nerve activity, and stress. In fact, today I shall be presenting a very short case study of what our lab and our students are doing a project on. It uses wearable ECG, wearable EEG, and all those things. After EEG, there is EKG, ECG, misprint. So we are able to diagnose and monitor chronic conditions such as cardiac arrhythmia, sudden cardiac arrest, and all those things. And even we have the capacity to prevent it as well as give early warning. Second, next, heart rate. Continuous monitoring is required. So we should be able to sense the heart rate and then apply some models or make some decision making algorithms upon it to have a good lifestyle. Other sensors may be EMG, particularly those who are in sports and fitness area, which is able to capture the local muscle activation and which can be also be useful for rehabilitation, motion study, assessment, etc. A very low cost sensor nowadays are in use, which are accelerometer and gyroscope. It comes in inertial IMU sensors, inertial motion sensors, and these are very cheap. These are built in your phones. Because of accelerometer, you are able to keep your phone from a landscape to portrait and vice versa. A very small accelerometer is able to judge the number of steps you have walked. It is able to judge the number of activities and monitor the activities you have done. So these are few of the examples. Other examples are today, which is which is in prototype stage and will soon be reality, and those are skin hydration and firmness. A patch is available which shall be able to check and monitor the skin hydration and firmness, temperature and galvanic skin response, which is able for superior thermal and fluidic transport and prevent hotspots and swelt buildup that causes inaccuracies. Ultraviolet and SPF sensing on the body to prevent sun damage. So these are few of the sensors which shall be useful for seamless sensing. Now, with advancement of technology, we are also seeing in the research labs various prototypes which is as small as a contact lens. Here in contact lens, you will be able to check what are the parameters, biophysical attributes, and monitor and prevent other diseases. Next, glucose monitoring. A large number of population in India and in world, diabetes is a very big concern. So how do we control or monitor? So one of in diabetes, when the body is not producing insulin, we need to continuously monitor glucose. And how are we able to monitor the glucose? At the moment, the most useful product which we see in every household is we prick the diabetic person, blood comes out, we put it on a glucometer and we check what is the blood glucose level. Now just imagine that instead of pricking and having an invasive technology means in which the person is pricked or is getting pain out of that technology. So instead of having an invasive technology, we can also monitor glucose by having wearable glucose monitoring patch. So is this a reality or is this a fiction? No, this is a reality. We are now having those patches. Actually in sweat, there is a component which increases or decreases as per the value of glucose. So what happens? The person just needs to wear those patch and it will be continuously monitoring the glucose level throughout your days on end. So this is a non-invasive technology and thus far better in terms of ease and monitoring for diabetic patients. Next, breath. Our breath tells a lot about our health. So, how are we able to monitor the basic components? So, there are technology available, which is still not very much popular in market, but given few more years, it shall be widely available in market in which lots of diseases could be monitored and judged upon the components, upon the just breathing into the device and it will be able to monitor it. So this is also a non-invasive technology, a very useful technology. Next, saliva. Even our saliva can be useful for predicting our health and various other components. So by giving you example of tear, breath, sweat, saliva, these all are available without pricking the body, without taking out blood. So these all are non-invasive technology and thus very useful and very easy to use. These wearable technology are advancing at a very rapid rate in the scientific community. By this graph, on the hand, there is a patch embedded, and this patch is made up of very thin embedded system which shall be able to monitor the glucose of the person. So idea is, how are we able to check the parameters? How are we able to design this module? So first, wearable technology needs to be very thin and should be able to be embedded on a wearable thing. For example, when we are saying watch has been used since centuries and centuries, but it was just able to show time. As the technology is progressing, as the sensors are becoming more small and cost effective, as they are becoming more powerful, the same watch which was used only for watch seeing time, now we are able to see messages, we are able to uh, use it as a personal assistant, use it as a reading device. Everything can be done on that watch. So this smart watch, smart everything needs the first and foremost technology needed is that the sensors should be as small as possible so that they could be carried on the body without being heavy. They should be thin and they should be able to be embedded. The second point is the transferring of data from a particular module to another module, that should be able to be done with micro transfer. So the mm the VLSI technology over here needs to be as small as possible. We are advancing obviously as much as possible. The third point is, when the patch is embedded, now the human body, it is a curvy and flexible thing, but electronics, it is a rigid component. So what is it important? So it is important that the thing should be able to be stretched and should be able to be interconnected and encapsulated. So these points are very important and most challenging in the terms of wearable technology. So are we looking at a dead end or is it a growing market? So this is a very growing market. Here at the moment, 56.7 million adults are predicted to use wearable devices at least once a month in 2021. In fact, in this particular classroom also, if I would have taken voting, many of you must have claimed that you are using the smart wearable devices at one or the other point of time. Even if you are not using smart wearable device as such, you are not using smartphone, but still you are carrying a smartphone. And in that smartphone, you are trying to use it for any particular application, whether it is motion activity detection. Those things are again indicated towards preventive healthcare. When you have taken an objective that you should walk for at least 10,000 steps a day, this is also within the field of preventive healthcare. So, and we are also looking at that at the moment adults are using an additional 3.8 million children and teens will also have such devices. So once we have those devices, there shall also be the concept of IoT, in which every device, everything shall be connected to each other. As we know, IoT means Internet of Things. Till this date, I'm sure you all have learned a lot about the concepts of IoT, how they are interconnected. In this particular session, I'm just talking about one particular application, that is healthcare, and that is used using smart wearables. So we are projecting that over 500 million wearable users were connected to 4G network in 2017. This is an old data. While the market is expected to grow by 89 million by 2023, connecting over 900 millions. So the IoT connection, the concept which you are reading right now, the FDP which is going on the topic of Internet of Things, this is going to be the next big thing. In fact, the topics of just Internet of Things have diverged into various application areas. So if you have heard about, there is Industrial Internet of Things, IIoT. IoT, when it has been applied to industry, it comes at Industrial IoT. When IoT is applied to medical field, then it becomes IOMT, Internet of Medical Things. So IoT is being specifically used for various areas and protocols are being developed for it. So now let us focus back on the healthcare system. In the healthcare system, when I'm talking about the whole healthcare, there can be medical area, there will be wellness area, there will be sports area. So let us talk about the first, medical area. So what are the things which are needed in medical area? We need vital signs should be monitored. In vivo and implants that needs to be checked. Chronic disease management needs to be done. Brain and eye movement needs to be coordinated. These all things are needed for specific disease or specific persons. For this, what are the things that are needed? It needs unobstructive patient monitoring. Obviously, I have a camera and I am able to monitor a person, but that camera has its own limitation of restricted to a space. The camera shall be able to monitor a room or a gallery or particular area. But with wearable devices, with wearable technology, you just need to wear the device and you are totally unobstructed. So monitoring can be done. Second is body augmentation. The wearable device should be such that it is not an extra burden. It should be as easy to use as you are using a watch. So it is a smartwatch. Diabetes care. As the number of population in the world having diabetes, so there is a special focus towards continuous monitoring of diabetic patients. First, when the diabetes is controlled. Second, when the diabetes has taken a toll on the health after being prolonged diabetic. We also need to have remote access to vital sensors such as ECG, EEG, EMG. So what are we looking at? What do we need? We need biofeedback patch. In biofeedback patch, we are getting continuous feedbacks. Hearing aid, which is a smart one. Insulin pump patch. There is a patch which shall be able to, without injecting, it will be pumping into your skin. Wireless ECG headset and all those things. Now let us come to the second point, wellness. A person not necessarily having any medical issue, but may need wellness area. For example, physiological monitoring, whether I am taking good care of my health or not, whether walking 10,000 steps a day or not. What is my weight? I should be monitoring my weight. Energy monitoring, gait and posture correction. So these, even though they don't fall under medical, they do fall under wellness. So how do we track? We can track sleep. At the moment in market, we have lots of products, which I shall be telling in detail what are the products that are available. So in the market, there are products available which is able to track sleep, emotion, stress, etc. It is able to control the obesity. It is able to interact with instructions that you do this particular thing. So what are the devices which are available? Smart sensor bands are available. Those are connected. We have interactive belts. We have sensor insoles. The third part which I would be focusing on is sports and fitness. In sports and fitness, the sports usually needs rigorous training and fitness monitoring. So the performance of the person needs to be monitored. There needs to be fitness monitoring. Virtual coaching is needed. The person should be unobstructive. So outdoor navigation and body cooling and heating, all those things are needed. How are we able to do this? We can do this by activity tracking, goal monitoring, direction data and location, optimal performance. The devices which are available for this are, we should be able to buy a harness. There are smart training shoes by Nike. There are activity trackers. There are GPS trackers. In fact, in fitness, sports fitness, there is a very famous video in which there is a famous footballer on whom every single angle on which the person was running and doing all sorts of activity, the monitoring was done. So how was it done? It was done using these wearable devices and these technology. After going through three broad areas in healthcare, let us move to the wearable electronics, which I shall categorize on the basis of use. So wearable device can be hand worn. At the moment, I am just segregating based on these areas, which are hand worn, which are head worn, which are body worn. So when I'm talking about these hand worn, so what are the things which are useful? Those are smartwatches. We have wrist wear, fitness band or Fitbit like of thing. We have smart rings. So these all things are hand worn. These are not obstructive in nature. What are the companies that are eyeing these hand worn devices? Those are Apple, Samsung, Jawbone. These are the companies. Next, head worn. When we are using, for example, smart glasses, like I told you in the first slide, what was the fiction and what was reality. So Google glasses are now a reality. Head mounted device, HMD is head mounted device. So these all are now being given in market by these companies. Last but not the least, body worn, and here we have lots and lots of variety. I was not able to put that much variety into the slide. So in short, there is smart textile. By textile, I have incorporated everything. I have incorporated, there are smart shirt available, there are papers, there are research papers and laboratories who are doing work on smart shirt, smart pant, smart socks, every means smart textile. Second is wearable pouches. I've shown a slide on wearable pouch which is able to monitor the glucose of a diabetic patient. Next is foot and arm wear. So these are also being given in market by various research laboratories, as well as it has been initiated by Intel. Now let us elaborate a bit more on these particular devices. So when I'm talking about hand worn device, so when I have told you about there is a smart bracelet available, what are the applications? Nowadays, with Corona, even what COVID-19 pandemic, even washing your hand is a very important step for your safety of your health. So there is a smart bracelet, intelligent M bracelet, which helps you to monitor how well you wash your hand. It is a fitness and health tracker. There is a wearable computer, M-on. There is watches. Smart watches are limitless. Lots of people are pitching in for smartwatch. Pebble smartwatch, Martin Notifier smartwatch, Apple Watch, Samsung Gear. So these are in watches. Now let us talk about wristband. On wrist, that could be MIT wristband, Tattoo bracelet, all those things. So when you put your wearable technology on a very small for a particular application, it could be useful for your health application. So these were hand worn. Next is your head worn devices. So smart glasses are widely available, and those are given by Google Glasses, Vex glasses, Optivent, ORA, Boohel. These are available. There are headsets which have EEG component sensor in it. Now you will think, what is EEG useful for? So today I shall be showing a small project in which this headset shall be useful for mental health care system. Nowadays, we are looking for holistic healthcare. We are not focusing just on diabetes. We are also focusing on mental health care. We are trying to be emotionally intelligent person. So stress and emotion recognition is also an important topic in our healthcare system. Apart from that, there are breathing masks. There are brain sensing headbands. There are communication helmets. So these are few of the companies which are taking lead in head-worn devices. Last but not the least, like I told you, there are body-worn devices. In those, smart textile, for example, there is smart t-shirt with integrated sensors and they can check for fitness trackers. There is smart armband by Mayo. There is safety baby worn blanket by Philips. These are the smart textiles. Foot and arm wear is there, wearable patches are there, e-skin is there. So these were till this particular time period, we have seen what is wearable technology. What are the examples of wearable technology? Is it a growing market? And if yes, what are the companies and projections of the future? Now let us talk a bit more about how can we have wearables useful for healthcare. So what are the components? So the first component for designing any wearable is sensor. The sensor could be of inertial sensors, biosensors, haptic sensors, any other sensor. The sensor should be able to draw or detect the raw data. After these sensors have gathered the data, they need to connect it to some central processor. So connectivity is also important. Now the Bluetooth connectivity is only between 8 to 10 meters. Wi-Fi is over 100 to 200 meters and GPS is a very good connectivity. So what is the range of connectivity you want to look for? Next point is battery. This is one of the most important challenges. In fact, I was reading a very interesting article by Veena Misra in North Carolina State University, in which she was talking about battery not being run or not being rechargeable, the battery being run by the own heat and motion of the person. So the wearable sensors, think about the possibilities if wearable sensor does not need to be charged. If you have a smartwatch and it does not need to be recharged again and again, if you have a smartphone and it does not need to be recharged again and again, it is simply being recharged based on the heat of the person and the motion of the person. So apart from those interesting research topics which I have seen, there are also conventional batteries, flexible batteries, and energy harvesting module. Energy harvesting may be in terms of solar harvesting or any other harvesting. Now let us talk about interfaces. So should we restrict ourselves to only one thing? No, we should be able to have speech recognition. The wearable device, if I'm speaking, then the Alexa, set the reminder to 2 p.m. The speech recognition shall be very useful for taking for variety of applications. Haptic and touch recognition, gesture recognition, etc. Now let us talk about what are the materials and algorithms. So when we have materials, when we are talking about smart textile, those textile, as we have seen, I had told earlier, electronics in wearable technology needs to be as flexible as possible, so that if we are wearing a smart textile, it doesn't mean that you are wearing a box. It is simply a cloth which shall be able to sense it. Flexible displays. Now flexible displays are getting into reality with OLEDs and other new developments. Accurate interpretation of measured data. So the data which has been collected by sensor, those data needs to be given to a classifier that should be able to correctly classify the objective. As the thing is about the objective is related to healthcare, we need to be as robust as possible. So when I'm talking about these systems, what is it? It is simply there is a consumer. On the consumer, there are sensors which is giving seamless sensing, continuous monitoring. Hello, yes.
Yes, ma'am.
Okay. Uh, am I audible?
Yes, ma'am. Audible. Yes.
Thank you. So there is a consumer. On the consumer, there is seamless, or there are sensors which is continuously monitoring. That is, it is seamless sensing. From seamless sensing, we need a connectivity which shall go to wireless connectivity, and there should be a continuous data analysis. So this is in few steps, and after data analysis, the circle comes back and the consumer is now informed. For example, if I take an example of glucose monitoring, from the sensors, the glucose level is detected, it has been transmitted, it has been analyzed, and then the consumer is informed. Based on those detections, we need to have the information conveyed to various stakeholders. So when I'm talking about digital health ecosystem, I need the person who is being monitored to be conveyed to lot of stakeholders, which include friends and family. If needed, in COVID-19 times, the community also needs to be informed. So it is not restricted only to family and friends. Then we need to specify to drugstore, to drugs manufacturer, and medical practitioner and doctors. So in this whole digital health ecosystem, when continuous monitoring is happening, all the stakeholders also get benefit of getting the information. So now let us talk about conceptual model for wearable devices. At first, the sensing is obtained from the wearer or from the environment also, if I'm talking about smart breath or something like that. Those wearable devices can be anything. From those wearable devices, the data is given to processing unit. Here, basic steps of data processing, pre-processing, such as noise removal, filter application, particular peak detection, all those pre-processing steps are done. After pre-processing steps, the main decision-making algorithm is put. And finally, a useful data is created. From raw sensors, here, information, useful data is being obtained. That data is provided to various users and stakeholders. Again, if we have an interactive wearable, we can also provide feedback to those wearable devices also. So let us talk a bit about applications. One of the interesting application I was seeing into was for mental health care system. In this, wearable device user has lots of sensors inbuilt upon him. For example, ECG, SpO2, accelerometer, electrodermal sensor, glucose monitoring sensor, EMG, blood pressure, temperature, heart rate, PPG, respiratory, etc. These sensors are built upon various devices such as smart glass, smart textile, smart watch, smart shoes, smart socks, smart bracelet, smart ring, and the most common smartphone. These devices shall be monitoring the data and be given to the gateway. From the gateway, those can be put on internet also, and those can be put on some medical server database also. From those database, it can be given to various stakeholders such as caregiver, healthcare worker, etc. Now, this is a basic module. From these, now for mental health care, what are the systems which we are designing? So I'll talk about the IoT. In this, the framework shall be, the sensors will be available. The sensors I would be particularly proposing for this mental healthcare system, in which I need to recognize the emotion of the person, the stress of the person. These are the factors I need to take into account. From these sensors, I extract raw data. From the raw data, there is removal of noise and missing values. After that, if the sampling rate of each of the sensors are not synchronized, for example, accelerometer is sampled at the rate of 20 Hertz and EEG is sampled at the rate of 100 Hertz. So the processing needs to be upsampled or downsampled as per the requirement. After that, the signal which was obtained, we can do windowing upon it, and then we can have some those windowed thing frame can be given to a particular classifier. So now I'm talking about what is a classifier. In classifier, I shall have a data set. For this particular mental health care system which was designed, we had three particular classes of stress, and those was, there is a neutral stress class in which there is no positive or negative emotion. The person is in neutral form. Next one was in which the person had positive feeling, means it was getting amusement. So when the data is being collected, there are specific tests, TSST test, in which those tests specify whether the person is in amusement. We are quantifying the stress limit also. So whether it is a positive amusement feeling or a negative stress emotion, we are able to quantify from that stress. So basically, there was a data set that was created for three classes. That data set was also pre-processed. The basic pre-processing shall be same because the noise needs to be removed, the missing values needs to be done, to be compensated for. All those things was done. Then the data was divided into train data and test data. From the train data, we need to model the parameters, and that classifier can be anything. So in the classifier, for example, here I have given the example of hybrid deep learning classifier. So that is, you must have heard about deep neural networks, convolutional neural networks, recurrent neural networks. So a hybrid deep learning classifier was modeled, and it was stored, the patterns, the model parameters were stored in the library. On the processing node, the test, when the person is continuously being monitored for the stress, those parameters will also be evaluated, and whatever the value was obtained, it was displayed on GUI. Now, the graphical user interface could be used, or it could also be transmitted to other stakeholders to see the monitoring of the person. All the parameters which was stored on the pattern library can also be kept on cloud, and vice versa. So if a smart watch has lots of memory available, then there is no need to transmit the raw data and do the processing on cloud. Whereas if there is limitation of power and computational memory resources on the wearable device, then you need to transmit on cloud. So this is not a strict or rigid structure. Here again, edge computing could be done, or centralized computing can also be done. This depends on the availability of energy, computational capability, and the requirements. So this was a prototype. The data set was collected by a well-known group, Philip Schmitz, and he had introduced a multimodal data set, which is wearable device for stress and affect recognition. By multimodal, it means lots of sensors were available, and this was using this sensor. So here the placement of Respiban and ECG, electrocardiogram, electrodermal sensor, electromyogram, temperature sensors, these has been demonstrated. Now, so this was one of the applications which our group was is doing. Next is preventive healthcare. When we have preventive healthcare, using in preventive healthcare, we don't have any disease, but we need to specifically control and prevent any untowards failing of health. So what was done? A personalized classifier was designed for human motion activities, and you must be thinking that personalized classifier are widely available, but here without asking from the person, if I'm not asking any raw data from you, the person, when the wearable device is being installed, then the person is asked for to walk for 10 minutes. If the person is giving in, but if we are able to extract that data without asking implicitly that what is being used, then it shall be very useful. So for preventive healthcare, personalized classifier can also be designed. So in this particular paper, what was done? A decision making was done based on, so there was a DSM criteria, data selection measurement criteria. This data selection measurement criteria was, for this particular result is shown for using conditional entropy. Whether the data which the person, when the person is walking, I need to make a personalized classifier of that person without him giving any implicit input. So what can be done? The data, we need to detect which data is useful, and then we need to give labeling also, because it is a supervised classifier. So how do we do? In data selection measure, we can have any criteria. For example, here conditional entropy is taken. So using that conditional entropy, if the conditional entropy of the data obtained is above a particular threshold, then we shall be able to use it. Otherwise, we shall discard that data. So thus, we were able to have a personalized classifier of the person without implicitly asking for those values for raw data. So thus, as we can see, when we are using, when there is a generalized classifier, it is not personalized, so the accuracy will be less. As soon as we are having a personalized classifier and we are using, so the percentage of accuracy shall increase. So these are few of the examples of which our students are, or I am working on, preventive healthcare or stress or emotional recognition, and this can also be expanded. So thank you so much. Any questions, please? Hello?
Participants, you may ask your queries.
Yes, please. Sorry, voice is not audible.
Yes, ma'am. Participant, you may ask some question.
Hello, madam. This is Kalavati. Can you hear me?
Yes, hello,
Ma'am, I am associate professor working in Kongu Engineering College, ma'am. The area of VLSI I am working. So my doubt is, recently I submitted one proposal for DST. So in that, I have analyzed the non-invasive techniques as collecting the images of the that is the collecting the images of the signs for vitamin deficiencies. So my doubt is that
The
so
images of
images of deficiency, symptoms of deficiencies, vitamin deficiencies.
okay, vitamin. Excellent topic, ma'am.
So in that I have one doubt, madam. So in that I gone for presentation level also. So since I think you may be the right person to clear my doubt. So can I use image data in the sensor, or I can parallelly go with sensor technology separately and in this image processing technology separately, ma'am?
Ma'am, it depends upon, do you have any constraint on, means when the topic is non-invasive technology or for vitamin deficiency? I suppose
Yes,
that you're
yes,
talking,
yes. Yes, yes. You
obviously,
are obviously correct.
okay, ma'am. So whenever the word non-invasive comes, so camera can be used and other methods can also be used. So apart from camera, are you using any other sensor also, ma'am?
As of now, I have proposed with this imaging techniques only. I have not used sensors. That is why my question is, with the help of the data itself, can I able to make the decision from that is the data which I collect from the imaging itself? Can I go for decision making, or I need to go for this sensing technologies also? That is my question, ma'am.
So, ma'am, actually, I had read a very beautiful article, I don't remember where, in which the article was specifying that even our sweat and other body fluids like tears, sweat, um, saliva, these all components, these all body fluids, which are uh, which can be assessed without not with non-invasive technology, these things also provide us clue about lot of things. For example, I had read the paper about glucose detection for diabetes.
Okay, ma'am.
So
Hmm.
I think, ma'am, that camera shall definitely be able to camera is a sure shot, image processing is a sure shot way of detecting the deficiency of vitamin, because the skin will be dull, there are few
Eyes
factors.
will be red, tongue will be have patches. So these are all the features I have collected.
Exactly. So camera is 100% effective way of detecting vitamin deficiency. Even our doctors, what do? They check the patient based on skin and visual, whether eyes are red or not. So camera is 100% effective way of doing it. But my suggestion will be that as the project needs some innovative thing, so you should go and search a bit about the sensor also, because if glucose can be detected by a patch, wearable patch, I'm 100% sure that there will be some sensors available which will be able to detect vitamin deficiency also. And if you are suggesting those sensors in project, I am 100% sure that it will be a novel work. You will stand out in the project proposal. Camera everybody is doing, so it won't be a very distinct proposal. Whereas sensor will be a bit challenging, but there will be lots of novelty concept into it. It depends upon you finding the literature, and then whether those sensors could be accessed in India or not, and you can put a proposal for that or not. Am I
Thank you,
clear, ma'am?
ma'am. Nice of you. Yes, ma'am. Thank you, ma'am.
Very interesting project, ma'am. Next question, please.
Any other participants? Please ask. Ma'am, in the previous question of Kalavati ma'am, uh,
Hmm.
I propose one Microsoft Kinect sensor for the same, for the
Yes,
collection of selection of the features.
yes, sir, yes, sir.
Maybe it
So,
can be used for the feature selection.
ma'am, sir is also suggesting a Microsoft Kinect sensor. That sensor has RGB camera as well as a depth sensor also.
Yes.
So you can check out the sir's proposal also, that whether Microsoft Kinect sensor will be more useful or not?
Any other
Sure, ma'am.
participant, please?
Sure, ma'am.
Other participants, please ask your queries. So, ma'am, I don't think there is any query.
Okay, sir.
Yes, ma'am. So I thank you, ma'am. We sincerely appreciate you for the taking out time from your busy schedule to provide us with such valuable information. And I wish you a great luck with all your future projects, ma'am. Thank you,
There
ma'am.
is a comment from Soumya.
Soumya, okay. Can you please write the names of the sensors? Okay.
What kind of sensor?
Microsoft Kinect sensor. हाँ, ये V2. मैंने ये लिखा ही था मैसेज, लेकिन now I am sending this message. It's my personal experience with this sensor is very good, and basically I rely on this sensor. This is very the characteristic of this sensor is very good, so you can use in your projects and your articles for this sensor.
Yes.
Okay, ma'am. Thank you, ma'am. Thank you so much for being with us.
Thank you, everyone.
Yes.